Hey YouTube, this is just another video example of how to find the rule for the nth term of an arithmetic sequence. But when we don't know both the first term nor do we know the common difference. So we've been given a couple of term values here. We say that the two terms of an arithmetic sequence, we know it's arithmetic just because of this, are the fifth term is 10 and the 30th term is 110. Well, what we want to do is come up with a rule for the nth term in general using this. And so again, just like in the last video, let's recall that the rule for the nth term of an arithmetic sequence is always consisting of the first term plus n minus 1 times the common difference itself. So again, what we're looking for here, the first term and the common difference, but what we've been given is a combination of n and an values here. So that is, again, our fifth term here. If we were looking at this in terms of an ordered pair, we say the fifth term of this sequence has a value of 10. So when you put 5 into the rule, you would get an output of 10. And if you were to plug in 30 into the rule, the 30th term has a value of 110. Recalling that every ordered pair here really represents a term number and a term value at that term number. Okay, so what we're going to do is we're actually going to substitute in these given ordered pairs, since we know that there are solutions to this sequential rule, and then work backwards by solving a system to find A1 and D. So here we go. We'll go ahead and plug these things in. We don't know A1 and we don't know D, but we certainly have been told a couple of values here that will help us out. We know that our fifth term, so we could go plug this in for n. Here we say n. Our fifth term has a value of 10. So the value of our term is 10. That's our an here, when we are at the fifth term, and that's our n. So really our first equation looks like this. We get 10 is equal to a1 plus 5 minus 1 is 4, so we get 4 times d. And I'm going to put a box around this. This is our first equation. And then our second equation would look like this. We would say, well, going and plugging in 30, the value of our an here would be 30. But if and only if the value of n, or the term, the value of our term, that's totally incorrect there. We say the value of our term an is actually 110. I was doing this in a different order than I did last time. We say is equal to a1 plus n minus 1 times d, where in this case we are at the 30th term. So here we get this. We get 110 is equal to a1 plus 29 times d. So here's our second equation. We'll go ahead and stack these equations, not that you have to stack them, but we're going to solve a system in order to determine what these two unknowns are. Recall that when you have two unknowns, you're going to need to have two equations to solve for this. And I think that when you're doing at least the arithmetic rules, it's really easy to just use elimination method. As a matter of fact, I'm just going to say I'm going to eliminate my a's 1 because they both have the same coefficient. I would only need to multiply the top equation maybe by a negative. Okay, so we get this. We get negative 10 is equal to negative a1 minus 4 times d. Oops, and this is all over 110 a1 plus 29 d's. And we're going to go ahead and sum these together. So our a's 1 cancel out. We get 100 evenly here, and we say that a negative 4 and a positive 29 come out to be a coefficient of 25 for our d. And you know, I think it becomes pretty intuitively obvious here that when we divide by 25, we're going to get a value for d that comes out to be 4. So basically what we're saying here is this, for this given sequence that we're discussing, from term to term to term to term, it's going up by 4 every time. That is our common difference here. Okay, so we already have discovered d. I'm going to go write that down up here. D is 4 and it's positive. What we need to determine now is the value of a1 so that we can write the rule for this sequence. So now that we know d, how do we find a1? We're actually going to go substitute this back into either the first equation or the second equation, and my advice is always going to be choose the one that has smaller values in it. So since 10 is equal to a1 plus 4 times d. Let's go ahead and take this value for d and substitute this back in here, and we'll be able to determine a value for a1. So we get 10 is equal to a1 plus 4 times d, or in this case d is equal to 4. In other words, we get 10 equals a1 plus 16, and subtracting 16 from both sides of this equation, we can go ahead and isolate our a1, and a1 comes out to have a value of negative 6. Okay, so I'm going to go write that up here, negative 6. And as a matter of fact, I'll write this on my rule. We say, well, if the sequence must start at negative 6, and it goes up by 4 every time. So I guess the second term would be negative 2, and the third term would be up another 4 is 2, and up another 4 is 6. And this is going to continue to go on indefinitely in this infinite arithmetic sequence. But what we want to do is this. Now that I have the rule, it says use the rule to determine what term in the sequence would have a value of negative 2. Now, there's a reason why I wrote this out, and the reason is is this, because I say negative 2, look at this. Negative 2 is our second term in the sequence. We say first term, second term, third term, fourth term. The idea is this. I already know that I'm supposed to be getting 2 for an answer, but how does the algebra support this? So in this case, we are given an an value, or a term value, and we're asked to find, well, then what position is it in this sequence? So what we're going to do is we're actually going to use our rule that we, I guess, haven't written yet to go and determine this. So our rule, what would our rule look like? Well, we know that an, in general, we say an arithmetic sequence has a rule that the nth term is equal to the first term. So we know our first term is negative 6, getting that from right here, plus n minus 1 times d, and in this case our d is 4. So I'm going to go ahead and distribute this through and clean this up a little bit. We say an is equal to negative 6 plus 4n minus 4. And when you combine your negative 4 and negative 6, we actually get a new rule, and we say an is equal to your first term, which is, I guess, a negative 6 plus a negative 4 gives us negative 10, and we say 4n here. So we say 4n minus 10. So here's our rule. Here's our rule. So what we want to do is we want to go now use this rule, 4n minus 10, which would find any term in this sequence, and we want to go ahead and plug this an value in for an and work backwards to determine what term would that have to be in the sequence. So here we have an equal to negative 2. So when our term has a value of negative 2, we're asking, then what must this term be in the sequence? So let's go ahead and solve this. It's just an algebraic equation, two-stepper. We'll sum 10 to both sides here. We get 8 is equal to 4n, and then we could discover the value of n here by dividing both sides by 4. And we get then it must be the case that it is the second term in the sequence. So that is, the second term in the sequence has a value of negative 2, or that is, we could say A2 is the one that had a value of negative 2. So we were able to determine this just by finding the rule first and then substituting in the value we know to go solve for the value we don't know. Cheers.